Let's do a bit of practice with long division of polynomials. Let's say I have x cubed plus 2x squared minus x plus 6. And I'm dividing that by x minus 4. So the polynomial on top is what we would call the dividend, and the polynomial on the bottom is what we would call the divisor. And the answer we get is going to be called the quotient, right? So how do we divide these? Well, we'll set up our long division like this. So the quotient is going to be on top, right? Like that. Your divisor goes out front, like that. And the dividend goes on the inside, x cubed plus 2x squared minus x plus 6, right? So when you're saying this divided by this, you read that over here as this divided by this, okay? Now let's actually do the long division. So the first thing you do is you say x cubed divided by x, right? This term divided by this term. What's that? Well, you're going to get x squared, right? Remember, x cubed divided by x is x squared. Hopefully you remember that from your exponent rules from grade 9. So I'm going to put x squared on the top. Why am I putting it here? Because I want everything to be lined up. So if this is a square, it has to go in the square column. So right above the other term that has a square, okay? So you have to stay organized like that. Once you have that, you multiply x squared by everything on the front. So x squared times x is x cubed. X squared times negative 4 is negative 4x squared. I'm going to subtract. When these two terms subtract, you should always get 0 because of the way we get these terms, right? They should always be the same. And then 2x squared minus negative 4x squared. So I'm minusing this whole line. So minus a minus, you get plus, right? So 2x squared plus 4x squared, that's going to be 6x squared, okay? And then I'm going to bring down a negative x just for the next step. I'll bring that down right away. Now, the next thing you do is you say 6x squared divided by x. So we're basically repeating the process, right? Before we did the x cubed divided by x, now I'm doing this 6x squared divided by x, okay? And we just repeat the whole process. Well, 6x squared divided by x is plus 6x. And then we multiply 6x times x minus 4. You get 6x squared minus 24x. And then we subtract these lines, just like this. 6x squared minus 6x squared. Again, you should get 0. But then negative x minus negative 24x is negative x plus 24x, which is plus 23x. 23x divided by x is 23. Put the 23 there. We're going to multiply, but actually you could bring down the 6 here first if you want, just so we have something to subtract by. So 23 times x is 23x. 23 times negative 4, you're going to get negative 92. Subtract these, you get 0 plus 98, right? Because 6 minus negative 92 is 6 plus 92, which is 98. So 98 represents your remainder. So when you're doing long division for the purpose of factoring a polynomial, you shouldn't get a remainder because the thing you divide by is a factor. But here we were just asked to divide, right? We were not told that x minus 4 was like a perfect factor or anything like that, right? So when you divide two numbers, most of the time you're going to get a decimal. That's what that remainder represents, that 98. That represents a decimal, okay? So what you can do now is you can write your final answer, right? You can say that x cubed plus 2x squared minus 6 plus x divided by x minus 4 is equal to x squared plus 6x plus 23, right? The thing we got on top, the quotient. That's equal to that plus 98 over x minus 4. So when you express your remainder, it has to be over that same denominator as this thing on the left originally was, okay? So that divided by that is equal to this on the right. Now, if you're not sure that that makes sense or why that makes sense, think about it like this. You could say 10 divided by 4, you should be able to figure that out. It's 2.5, right? 2.5. Well, that's the same as saying 10 divided by 4 is 2, but then you do 2 times 4 and you get 8, and then you subtract and you get 2. So if you did long division, you get 10 divided by 4 is 2 with a remainder of 2, right? Well, how do you express that? Well, you would say, therefore, 10 divided by 4 is equal to the 2 you got plus the remainder of 2 out of this denominator here, the 4. So you put the 4 on the bottom here as well. And if you don't do that, then you just have 2 plus 2, which that's not right. But this is 2 plus 2 over 4, which is 2 plus a half, right? So 2.5 or 2.5. So you always have to express that remainder over the denominator, the thing you were dividing by, okay? Hopefully that makes sense. Let's do one more long division, and then we'll practice synthetic division after that. Let's say we have x cubed plus 2x minus 4 divided by x plus 1. So we'll write it out. X plus 1 into x cubed plus 2x minus 4, just like that. X cubed. Oh, and actually, there's one trick to this question. Remember how we want to write everything in the proper columns? We need a column for x squared. So I'm going to put plus 0x squared because there's no x squared term here. So plus 2x minus 4. So you actually want to leave a space for that, right? And you can use a 0x squared to represent that. Okay, now we're ready. So x cubed divided by x is x squared. So I put in the x squared column. We multiply. X squared times x is x cubed. X squared times 1 is x squared. Subtract. It's going to be 0 minus x squared. Bring down your 2x. Negative x squared divided by x is negative x. Multiply. Negative x squared minus x. Subtract. You get 0 plus 3x, right? Because 2x minus minus x, it's like adding. So you get 3x there. Bring down your negative 4. 3x divided by x is 3. 3 times x is 3x. 3 times 1 is plus 3. Subtract these, and you're going to get 0 minus 7. So your remainder here is 7, but your answer is on the top here. It's x squared minus x plus 3. So we could write out that x cubed plus 2x minus 4 divided by x plus 1 is equal to x squared minus x plus 3 minus 7 over x plus 1. So when you divide those, this is the answer you get. You get this polynomial, but you have a little remainder there on the end. Okay? And if you wanted to, you could multiply both sides here by the x plus 1 to get rid of it and then show what the original polynomial is equal to. Again, if you want, right? So you could say that like x cubed plus 2x minus 4 is equal to x squared minus x plus 3 times x plus 1. And then you would just have minus 7 because the x plus 1s would cancel. So this big polynomial is equal to these polynomials multiplied together and then minus 7. Okay? So that's another way you could write it. Just like how with our example before where we did 10 divided by 4 is equal to 2.5, you could say 10 over 4 is equal to 2 plus 1/2, and then you could multiply both sides by the 4, so you would just get 10 equals 2 times 4 plus 4 times 1/2 is equal to 2. That's kind of what we're doing in this step here, right? We're basically doing this, where that 2 is your remainder, just like how the negative 7 is your remainder, right? And that would be 2 times 4 is 8, plus 2 is 10, so of course it works here. So of course it would also have to work here, right? If it works with numbers, it should also work with polynomials. But that's not the most important, just make sure you know how to get your final answer and do this long division, okay? Now let's try some synthetic division. Synthetic division is always a good tool to have because you can do it pretty quickly, right? It's good for a test. So let's do 2x cubed minus x squared plus 4x minus 11 divided by 2x minus 3. So we set it up kind of upside down division symbol, right? Usually it's like this, but we're doing the opposite. Okay, so what number do I put on the outside? Well, it has to be the x value here that makes this equal to 0, right? If this thing underneath was x minus 1, we would use 1. If it was x minus 2, we would use plus 2. If it was x minus 7, we would use plus 7. But instead we have 2x minus 3, so I got to solve for x here. So I'm going to say 2x minus 3 is equal to 0. Therefore, x is equal to 3 over 2. So I'm going to put 3 over 2 here, and then on the inside I'm going to put my coefficients, 2, negative 1, 4, negative 11. And now we can start. So I'm going to bring down my 2. 3 over 2 times 2 is 3. 3 and negative 1 make 2. 3 over 2 times 2 is, again, 3. 4 and 3 make 7. 3 over 2 times 7, that's going to be 21 over 2. And now to add these, I need a common denominator. So instead of negative 11, I'm going to make that negative 22 over 2. Negative 22 over 2 plus 21 over 2 is negative 1/2. So negative a half is your remainder, okay? Meaning that your answer here can be represented as 2x squared plus 2x plus 7 minus 1 over 2 over the 2x minus 3. That's what your answer is when you divide those two polynomials. And you could simplify this. You could put that 2 on the bottom, on the outside, right? But basically, that's your answer. Let's do one more. Let's do 5x to the 4 minus 3x cubed plus 2x squared plus 7x minus 1. And we're going to divide that by x plus 2. So we set it up. Because the bottom's x plus 2, I just put negative 2 over here. And then I put my coefficients. Just like that. Now let's go through it. Bring down the 5. Negative 2 times 5 is negative 10. Negative 10 minus 3, negative 13. Negative 13 times 2, 26. 26 and 2, 28. 28 and negative 2, negative 56. Minus 56 and 7, minus 49. Minus 49 and 2, 98. 98 minus 1, 97. So that's your remainder. So the answer to this is going to be 5x cubed minus 13x squared plus 28x minus 49 plus a remainder of 97 over x plus 2. Right, and that's it. So you just stop here because you just asked to divide these two things. It's not like the previous video where you're asked to completely factor this, right? Because this isn't a factor. We're just dividing by a random polynomial and seeing what we get, right? This is just practice for dividing. Okay, so that's all you have to do in this case. So in the future, you'll probably have the option to use synthetic division or long division, like if you're doing a test or whatever it is. So do whatever one you're most comfortable with. But at times you might be asked to use one method over the other, so definitely familiarize yourself with both.